咩啊 ？social level analysis 嗰個係 trailer 嚟嘅。真係會見到嘅喎，嗰個係 YouTube 嚟嘅喎。嗱，我要知道點樣 at 你入嚟咯，反而係。我 send 條 link 俾你，你 click 咗落去睇下會發生啲咩事。你可以去 YouTube 睇嘅，應該都會見到嘅。我而家 send 俾你。係啊，你睇到 YouTube 啫嘛，但係你要 join 入嚟先得㗎。你都未 join， 我 send 你見到條 link。有 delay 咯。咁一定有 delay 㗎。你仲未過嚟？唔係啊，你開你 Gmail 見到咧，你開 Gmail 啊，我頭先 send 咗條 link 俾你。你試下 click 落去睇下會唔會得 join。係 join。哇！你想模糊啊，大佬？
點解唔識教喎？
得啦，喂，即係而家應該係有兩個頭啦。係啊。哈哈。
等先，我哋兩個係我同你都睇到啫。
係啊。
咁人哋咧，人哋睇啲咩啊？
人哋咪睇到
馬路。
係啊，應該兩個頭都睇到喎。係咯。係啊，係咯。打咗嚟啦。係兩個頭都睇到喎，應該。
大聲嗰聲，要收聲。
梗係有啦。Okay. The Hong Kong R user group 300 unconference will be start in 25 minutes. So stay tuned. And we will do some stupid stuff right now because we need to test something. And the official starting time is 8 o'clock. So stay tuned.佢 detect 到邊度有聲，佢就會彈咗去嗰度㗎嘛。係啊。有 delay 嘅，都相當 delay 添。但係都係可以接受。
轉 screen，一定我咁。
嗱，其實咧，如果你要轉 screen 咧，你見唔見呢度有個掣叫做 screen share 啊？
點我睇到你嘅？我轉咗 screen share 定係？
你轉咗啦嘛？我 stop 咗我先，跟住咧就要，跟住你咧有揀上面有得揀present to everyone 噶嘛？咁即係我要 send 埋條 link 俾阿 Jane。如果唔係佢唔知點做。
咁啊，覺得你睇到啲咩而家？
要等一陣先，我見到你個畫面，我見到你個畫面叫做 screen share。誒，見到㗎，不過佢聲，因為佢聽到我講嘢嘛，佢聽到我講嘢咪變咗我 screen 咯。你試下對住個 screen 講嘢。
喂！
咁咪變咗你咯，係。
我點解可以將嗰個字較大啲啊？
你知 R 輸嘢。
係啊，記得咗。好似係呢個，好似有啲。OK。喂！
係。
都好細，係因為你嘅 screen 細啊。
嚇？
係因為你嘅 screen 細嚟嘅。
係因為我頭先呢啲先係。
唔係都 OK 嘅。
OK 嘅。爭咗個問題，而家點樣將佢 set 到咧？永遠都見到有個頭喺下邊咧，會好啲我覺得。你先 send 咗條 link 俾阿 Jane 先。
跑平。
嗯？
今日去跑平。
係呢個。
呢個幾驚人嘅。
咩啊？
佢有少少即係發燒嘅感覺。唔知幾驚人到你幾開始。
真是。點樣 即係總有方法係可以。
我諗緊頭先人哋講嘅想仔路，佢哋做嘅事咁嘛，我哋話一定有水，一定唔難咁樣。
所以我喺度諗緊，其實係咪可以？其實我係咪可以咁樣 click，然之後揀話我 P，即係我揀邊一個人而家 present 嘅應該得嘅。係啊，應該得啦。跟住我揀你啦。係咯，有得揀㗎。即係例如到第二個人嘅時候咧，我可以幫你揀，即係 switch 去邊一個人。
大家諗下喺個電話，你都試過
咩嚟㗎？你嗰個 iPhone 嚟㗎？
唔係啊。
有啊，等一陣啊。
就打開佢 share out 其他啊。你而家玩呢個咩？之後咯，
之後得啦，梗係。你都識咗啲聲。
先講嗰個都可以 capture。
有乜所謂啫？I don't mind 好。 決定去教火的少年，其中一位想記得小鍛鍊，實在是孩兒，報了名便算。另有別個勇敢的成員，為了要共愛侶一起耕田，靜悄，便決定轉身轉。又為了母親的勸勉，在這社會最怕走得太前，怕了，便歸家往後轉，啲確錯嘅。We haven't started yet, so.係啊，但係唔知佢會唔會出現。佢話睇緊啊。係咩？係咯。Just check the mic feed. 我每次入去咧，我就要去翻 Facebook 嗰度定。係啊。我想睇咧，我就所有。跳出去喎，係嘛？唔 click 翻嗰條 link， 見到啲咩？有冇就 join？ 我而家出咗去。我見係啊，你出咗去啊。你叫咩啊？ Nè, cái phim phim Hi Jane.
Hello.
Hi.
There's someone beside you?
Yeah.
Okay.
It's Jeff.
Jeff.
Jeff is one of speaker.
Oh, okay.
Yeah.
Cool.
Còn có cái con nhung mà. Jane, if we need to present, there is a button in the left-hand side called screen share.
Yeah, I was just looking for that.
Yeah.
Okay. So let's see if I can click it. And then make it entire screen.
Yeah.
Whoa, what's happening?
And then minimize the hangout window and then show your PowerPoint presentation. Yeah.
Like this?
Yeah.
Oh, okay, cool. Let's see.
No.
Yeah.
Who is on carrot? Carrot 係Jane 個。
Yeah.
So is Guy Freeman also presenting on Carrot?
Maybe.
Maybe. Okay. Stop sharing.
Yeah, I. You need to mute also the microphone, right?
Nice.
佢先啦，你有花嘅花。
Okay. Chuyển 翻你個頭啊！
咩啊？
轉翻你個頭啊！
我唔想出個頭啊！出個真係好得。
Show your face.
邊個轉咗個？
轉咗咩？未轉。Okay. 見到啦 ，Yeah。啊？ which
Cheers.
Okay, we start very soon, so please be prepared.
Okay.
If you have any questions about our talk today, you can ask in the Facebook page, in our Facebook page, on the event message. Just leave a comment, and then we will answer your questions after our talk, after all of our talk. So, secondly, the topic for today include, as of now, we have 3 topics. I will talk about the data analysis pipeline and Rio. And Jane will talk about some models, prediction models. And Jeff will talk about the graphic systems in R. And if Guy Freeman can make it, he will talk about a machine learning, statistical learning library called a Carrot. So let me start my talk now. Let me switch. Okay, my talk will be on the data analysis pipeline. And I want to show you a very typical data analysis session. It should be something like this. By the way, this one is the Jupyter Notebook, which is an interactive web version of R. For example, this code, I read in a data set of NBA. As you can see, this is a data set of some players, and for example, which team they belong to, the positions, and there are 2 columns which is important. The first one is X3P, which stands for the number of 3-point throw they successfully get. And X3PA is the number of attempts they tried. And finally, the final column is the PTS, which meaning the total number of points that particular player gets in that particular season, which is 2012, I believe. Suppose I want to calculate the ratio between the number of 3-point throw that particular player get and the number of divided by the number of attempts. And I only want to calculate this ratio among players with at least one attempt, because if I include those players who never fold any 3-point, then I will have the problem of divided by 0. And then I want to sort the data by that particular ratio. The method that you may use is to first create a new data frame that using a selection criteria, using a logical vector like this, and then create a new column called X3PP, which is this calculation, and then create a new data frame that include the player and the X3PP, and then sort that to column using the X3PP values. And if I want this, the result should be like this. For example, this player have the 1, X3PP equal to 1, meaning all their 3 points are success. And this player is 66% and things like that. As you can see, this code is extremely tedious. And one important point is that if you look at the LS, which is list out the word space, I need to create an intermediate called NBA0, which is an intermediate. And those intermediate in the programming world, we call it side effect. And side effect is not good, particularly for those functional programming. And there is some reason for this. You can follow this link. By the way, I will upload this this notebook later onto our Facebook. The second problem is for the code that I use above is that those code cannot compose. Meaning, for example, I need to include also the POS column in the data frame that with the sorted X3PP. I need to write that data frame code again, like including this line, and then I need to order it by the X3PP again, and then I will get that data, which is tedious in my opinion. And suppose I need to calculate the mean X3PP values of the player from each particular position. And in order to calculate this using the base R, I need to create even more side effect. Because, yeah, as we all know, if I need to calculate the X3PP per group, I use the function called tapply, and then separate the player by the POS and then calculate the mean. But this method didn't work because if you just type the POS, it cannot calculate. But you need to have also the name of the data frame, like NBA or something like this. But you just create this data frame. You don't have a name for this data frame yet. So you can't. So I need to create one more data frame, one more intermediate, so that I can use the tapply like this. In order to do this, I create one more intermediate, which is the X3PPDF. By the way, actually there are some way that I can calculate the mean for each position without creating those intermediate using a function called width, which will create a temporary namespace so that I don't need to create that intermediate. But as you can see, this code is somehow counterintuitive, meaning I don't know what it means. For example, okay, I want to prove my point that if I use the width function to do the calculation, I don't need to create all those intermediate. But as I say that, this kind of code is counterintuitive. So some good people create a package called dprior. As you may know, there is a package called prior. Dprior is the version of the prior that is specialized for the data frame or the tabular structure or data frame-like structure. In this code, I remove all the objects in my workspace, and then I read in the NDA again. After I read it, and then I do the ls, I only have the NDA. And the prior package solve the problem of creating intermediate by introduce some function. They call it data manipulation verbs. And let's have a look at those verbs. For example, the first verb is filter. Filter meaning selecting some rows based on some criteria. For example, I want to select the row that have the x3 PA larger than 0, and I evaluate it. It takes some time. And after I evaluate it, it should select all the rows that with the x3 PA larger than 0. Okay. And another verb that introduced in the dprior is mutate. Mutate is for creation of new columns based on some calculation. For example, I do the filter of the NBA data set with the data that x3PA larger than 0. And then I want to calculate a new column called x3pp equal to x3p over x3pa. And then I do it. It should create a new column called x3pp. But as always, because the data is quite large, so it takes some time. And I want to prove that it actually do the calculation. Yes, it calculates the x3pp. The next verb is arrange. Arrange is for sorting. Sort the row by a column, by the values in a column. For example, I want to sort the data frame using x3pp, then I can use the arrange and then x3pp. If you need to reverse the order of the sorting, you can use a function called desc, meaning descending order, and try that. And now the data frame is sorted by the x3pp. As you can see, those with x3pp equal to 1, meaning the maximum values are sorted, ordered in the first few rows. And move on. The next verb is called group by. Group by meaning grouping the data frame by the values in a particular column. But even though I ask the group by function to group the data frame according to the POS, it will not give me any meaningful results, because after I group it, I need to ask the data frame, ask the dprior to do further processing. Okay. For example, after I do the group by, I can use another verb called summarize to ask dprior to calculate the mean x3pp according group by the POS in the data frame. Okay, as you can see the results, it calculates the mean x3pp of all the players. For example, if they are center, the mean x3pp is these values. And in the above code, there is a ls, meaning I want to list out the names of the workspace right now. After I do all these computation, the namespace, the workspace is still very clean. Therefore, I still only get the NBA. I don't need to create any intermediate. By the way, I think I missed one verb, which is select. Select is easy to understand. It just extract some particular column from the data frame. For example, I want to select the player, POS, X3PP, X3PA, and X3PP from the original data frame. I can use the verb select. But the problem is, if you writing code like this, you need to have a how many level of nested parent, which is extremely difficult to read and extremely difficult to write as well. So because the readability matter as well, so and it is difficult to read those parents. So some people introduce a new operator like this from the Magritte package, and people usually call it a pipe operator or call it the then operator. And this operator is recently very hot due to the dprior package. And I want to show you how this operator works. For example, the NBA dataset, I can pipe it to the filtered verb, and the dots in the filter will be replaced by the left-hand side of the pipe operator. For example, this one, it works. Take times, but it is effectively equivalent to the code like this. Okay, it's just replace the NBA into the dot. Okay, and if the position of the argument is the first, you can even skip the dots, meaning this one works. You don't need to add the dot in the first position. It takes times. And then I can pipe the results to mutate and then do further calculations. You don't need to do all those nested parent anymore. And arrange the order. The problem of our calculation is like this. It can be illustrated here. For example, let's look at the X3PP. The X3PP of some pair is 1. Why? Because they only obtain 1 if they success. Their probability or their successful rate become 1, which is not good. Actually, we can add more criteria to the arrange verb so that it can arrange by 2 columns. For example, I want to first arrange the column by the X3PA and then by the X3PP. Let's see what the result is. Okay, now we first sort the data by the X3PA and then sort the data by the X3PP. And then you can see that okay, the top pair in terms of 3-point fold is Stephen Curry, which makes sense because he is good at floating those, right? And he is the MVP of this season, by the way. And after we do the arrange, we can pipe further the result to select by selecting only the row we like. Okay, and then we can do the summarize. And the advantage of writing code like this is that we can compose, because, for example, we want to add something. For example, I want to arrange the order of the mean X3PP. I can just add one more operation, and pipe that. For example, I want to sort the Linux 3pp. So I just need to add the pipe and then arrange it. And we can also pipe the results to anything that is beyond the D prior. For example, in this case, I want to pipe the result of this particular data frame to ggplot. And then it will plot out the results. Okay. And by the way, in order to prove my point, after all this calculation, our workspace is still very clean. This is another example. I want to group the player according to whether or not they have ever attempt any 3-point by creating a new group by variable called x3p suitors. And then I use the summarize function to calculate the number of player, the total of point the total number of PTS they got, meaning the total number of points they got, and also the mean values. And then I can show that okay, those who ever attempt any 3-point get a higher mean PTS and also a higher total PTS. And also we can add some more group by variables. For example, apart from the x3p suitor, I also want to group the data by POS and then do all these summarized operations. For example, the center, the player who are center, and then they never attempt any 3-point. Their mean PTS is 173, and the center whoever attempt any 3-point is 648. And from this analysis, I found something very interesting. For example, there is one shooting guard who never attempt any 3-point, and he never score any, as you can see from here. In case you don't, okay, I'm not an NBA fan, and I know very little about basketball, but I know that shooting guard should be the one who shoot 3-point, right? I want to know who this sucker is, okay? And I can use the filter function to do that. For example, I can just filter the shooting guard who never attempt any 3-point, and I know that that guy is called Matt Carroll. And apart from the D prior operation, we can use the then operator provided by the Margarita for the context beyond the D prior. For example, in this example, I use the then operator to create a pipeline that do the cluster analysis. For example, iris data set, and then I select the data that is without the columns species, and then I use a function called Daisy to do some pre-processing of the data, and then use the function called Agnes to do the cluster analysis. And then I only want to retain 3 groups, 3 cluster, and it can give me the labels of all the case according to the cluster analysis. And for this case, I modified it from the mass example. It's actually an example provided by the mass. For example, I have a data called anorexia, and then I do a GLM, which is the linear model. And then because the GLM, the first argument is not the left-hand side, so I need to use the dot notation to denote that I want the anorexia to replace here. And then I pipe the GLM model created to the summary, and then it will give me the summary of that GLM. Okay, I don't need to create any intermediate. In case you want to know more about the dprior, you can follow this link, which is the link provided by the creator of the dprior package. And there are some more pipe operator beyond the then operator from the Magritta package. You can follow this link if you want to know more about the other pipeline operator. And in the final part of my talk, I want to introduce a package that is freshly updated on the CRAN called Rio, which is the new version of the Rio. Rio is your first and last stop of your data analysis pipeline, which is a collection of functions for reading and writing data from and to a data file. And the Rio package only have two functions. One function is called import, and another function is called export. And for example, I can use the import function as a replacement of the read CS3 function. In this case, I can show that it works. It reads the data and then do the filter. And another function is called export, which is exporting the results. It can guess which format of data you want to export. For example, if I want to export the data as XLSX, meaning I want to export it as an Excel file, it can do it. And then I can import that Excel file back, and then I get this data. And the format supported include all this. Most importantly is the Excel file, XLS and XLSX, and also SPSS and JSON file. These are the three most important data formats. And some usual suspects such as the CSV. And I want to skip this. I want to try this. I want to export the data analysis that we do and then export it as a JSON file. And then I import it back. It will give me the results. Okay. And if you don't like to use it in the pipeline, actually you can also use the Rio package, the import function, using the traditional way. For example, using the arrow operator, it still works. And finally, about the pipeline operator. I want to show you my comment about the pipeline operator in the early 2014. Okay, I comment that, okay, the pipeline operator is the new hit. I can foresee this ugly, lazy construct will slowly make our code more Perl-like. Okay, Perl have the reputation of being an ugly language. But after my intense usage of that pipeline operator, I find it is not necessarily making the code ugly. I want to introduce two concepts. Okay. One concept is called a prefix notation of calling functions like this. Infix notation is also common. For example, this is a common way of using the infix notation to do the calculation of 2 plus 3. And actually, you can write it as a prefix notation, which is not common. And also the colon operator, we also use it more commonly as an infix notation. You can also use it as a prefix location like this. In order to prove my point, they are equivalent. Actually, in R, we mix the notation of prefix and the infix. Okay, so introducing a new infix operator like pipe, we would not necessarily making the code more ugly. For example, in the same token, this is the method of, this is the calling the function using the prefix notation. This one is the infix notation in the purest form. For example, 100, and then I pipe it to the how long function, and then calculate the mean. And after I use it for some time, I get it. Maybe the best practice for us to write some good out code is to know when to mix the infix and the prefix notation to make the out code more idiomatic and expressive. For example, I will say that, okay, the purest form of infix notation is not good, because if you need to tell a story from this code, it's meaning create a scalar of 100 and then pipe it to how long and then calculate the mean, which is not intuitive. But this one mixing the infix and the prefix. For example, this one is the prefix. I call the how long and then pipe it to mean. I can tell a story, which is meaning I'll generate 100 random number and then calculate the mean. And also, the purely prefix form also works, meaning calculate the mean of 100 random numbers. Okay, in order to prove that they're equivalent. Okay, actually they are equivalent. The difference is very small because it's still random. This is the end of my talk. If you have questions, you can ask it in the Facebook page, and I will entertain it after other speaker. And I want to pass it to Jane. Okay. Okay.
So let me do the screen share. Okay, so I wish I used something cool like Jupyter, but instead I just have a regular PowerPoint type presentation. So I will talk a little bit about the Carrot package and how I used it. So the Carrot package is mostly a machine learning package, I think, and it's a package that tries to streamline the modeling process by having a lot of different types of model that you can do, sort of all under the hood, so that you can just call one function, like the predict function or something, to do the prediction for all types of different models. There's a lot of online resources for this package, which is partly why I started using it. It's really easy to get started. So there's a link to a YouTube video where the creator of the package, Max Kuhn, talks about it. And then there's a Coursera course, which I have been taking, called Practical Machine Learning, hosted by Jeff Leake from Johns Hopkins. So it's a 4-week course. So it's actually fairly short for you to get like a full idea of machine learning. You probably need to go beyond that course. But this course focuses very much on sort of what are the commands you need to start using it. And it's a lot of what I will talk about I've gotten from this course. So I'll talk a little bit about the very bare bones of what you would need to do in order to create a model in Carrot. And then actually earlier today, I played around with it a little bit today, so I'll show you what I have. And because it's very new to me, so feel free to tell me if I said something wrong, or ask me questions. So in theory, it could be very simple. Whenever you want to do machine learning, you want to separate your data into training and test sets. Better yet, if you had another independent data set that you can use later to verify your model, that's even better. But a lot of times, you're given a data set, and you don't have a separate independent data set. So what you want to do is just split that data set and partition it and create it into training and test sets. So they have a function here called create data partition that does that. Once you do that, you probably should plot it or look at it, and you should think about how you might want to transform your variable. So there's a lot of function there that also does that. I think standardize is not specific to the Caret package, but pre-process is. So there's all sorts of ways you can pre-process it, like maybe subtract it by the mean and divide by standard deviation to make all the features approximately on the same order of magnitude. And then once you're happy with the way that your covariates or your features are transformed, you can train the data with just the function train. And eventually, like after you've trained your data, you want to evaluate the performance of your data on the test data set that you have set aside earlier, using functions like predict or confusion matrix, etc. So the very basics of training is that you can just create data partition, and the y here is the y variable that you want to partition on. So if your response variable is 2 categories, like yes or no, then the create data partition will take that into account when creating a data partition. So it tries to not have your training data be all of the category yes or all of the category no. And that's why you can specify the y, and then you can specify the p, so the proportion of data that you want to be the training data. Once you do that, you basically do simple things like this. Okay. Do I have screensaver? Someone say that?
I don't think you have.
Okay. I just wonder whether you can see it. Okay. Okay.
Can you see it from your screen?
See what from my
The screen sharing. I mean.
Oh. I thought I was in screen sharing. Was I not sharing?
No.
Oh.
Oh yeah, now minimize it and then show your yeah.
Hey, so
yeah, cool.
Okay. I was just staring at the screen for a while.
Okay.
Okay. So
okay.
Let's see. Yeah. So you can create a training data this way. The in-train just gives you like a list of numbers. Sorry, let me make it full screen. How do you do that?
Present. There's a little button called present.
In the slide or in the?
No. Can you see the blue button called share? Okay. Yeah.
Just like this?
Yeah. Cool.
Yay, okay, now it's working. Okay. So create training data, create test data. I think this is self-explanatory. And then you could do all sorts of pre-processing like this. So you can write pre-process on your training data. If you wanted to center it and then scale it by the standard deviation, like I was talking about. If you wanted to create dummy variables, this is a way to do it. And you can do things like remove the covariates that only have 0, so that they're not going to be very helpful. And if you wanted to have your covariates be sort of more wiggly, you can use the spline basis, so using that function, BS. And of course you can do a lot more. You can do PCA and look at your data and so on. But mostly what you want to do is you want to do it only on the training data, so that you don't end up doing it also on the so you don't end up pre-looking at your test data and overfitting. I think after you do the pre-processing, the next step is train. So you should train your model, and then eventually you'll have the predict step. I'll show some of my code later. So after you train your model, you can predict, and when you do the predict step, you want to probably use the optimized model. So in any kind of model that you end up fitting in your train step, the final model is the optimized model. Usually they call it optimized because it has the smallest RMSE. And then I think like a lot of other packages, depending on what model you use, they'll give you different types of predictions. Like you may need to convert things to a factor vector if your original model was a logistic regression and it just predicted probabilities. So I wanted to fit my own model, and the context is that I'm studying biology, and I wanted to try to predict disease genes. Using functional genomic or molecular biology signals. So my Y, or my response, is sort of the genetic signal, and all my features are sort of the functional, or you can think of it as molecular biology signal. This picture is supposed to show you all the different kind of functional genetic stuff that you can have. So I thought I'd try two models. One is something that's fairly simple, a general linear model, or more specifically, a logistic regression. And the second one is something that's a bit fancier, called a random forest. So we'll see how they do. So in the first model, we're fitting a GOM, and I had train, and the important part is the important part is that you want to specify the data as a training data, specify the method as GOM, and specify the family, in this case is binomial for logistic regression. And I wrote my covariates out because I wanted to make sure I knew what I was fitting. But you could, like anything, you could do tilde dot for it to fit all the covariates. And I was really surprised, actually. This one fitted really well. The RLC curve looks amazing. So I feel as if I must have done something wrong. But anyway, you can use the library, PRLC, to plot it. And in this case, like I was saying before, you can use predict on the model that you just made, but now feed in the test data and have it output the response variable, and it will give you these predictive values. And you can do this RLC on the real values versus predictive values, and they'll nicely formulate an RLC for you. You can also just print out the model. So if you just print name of the model and final model, it tells you things like the coefficients of the model, the degrees of freedom, things that you usually see. And that's the final model. But if you just look at the GLM object, so the training object itself, then it'll tell you things like, well, what was the sample size, how many times it did the bootstrapping in order to come up with this result, and like what were the range of models it fitted during that time. So the range of RMSEs are here. So next, I try to fit a random forest model. So the difference here is that there's the method equals RF for random forest, and similarly you have data equals train. And so I should say the last model I had, like you can see, the sample size was about like 3,000, and that took a minute to run, less than a minute. I didn't clock it. And this one, the random forest one, took about half an hour to run. So it takes longer, as you could probably expect. So you can do the same thing, just like output what the model looks like, and they'll tell you that similarly it did this much bootstrapping, and this is what it tried to tune, and the final value used for the model was mtry equals 2, which I think means that at each node they used 2 covariates, which seems very little to me, but I don't know. That gave us the best RMSE, which is why they did it. So you can also ask it to give you the variable importance. So they tell you how they calculate the variable importance. Basically, they take the out of bag portion of the data, they permute it, and they look at the accuracy between the tree that's fitted after permutation and the tree that wasn't fitted after the permutation, so the original tree. And that gives you some measure of importance. And so here, they range a lot. I think that means that the biggest number means it's the most important. One thing that I thought was really cool while I was going through the practical machine learning course was that you could actually combine predictors. And I'm told that when people do Kaggle competitions and so on, that combining predictors is the best way to win these competitions because it almost always improves your accuracy. So some code that I basically copied from that course is that you can so these are the 2 models I fit. One is a GLM model and one is a random forest one. You can do the prediction on both, put them into a data frame with the original test data. Okay, so this is the test data. And then train it using the method GAM, which is general additive model, like a very flexible model. And this trained model you can then use that to try to improve your prediction accuracy, and you can use that to predict it again. So just because I just tried it, so I haven't verified that it actually does improve my prediction accuracy. But I think that's pretty cool. So that's the end of my talk.
Thank you. Yep. And let's pass the mic to Jeff. He will talk about the graphic system of R. Okay.
Right. Thank you, Hong. Well, at first, we were advertised saying that we are going to talk about ggport 2. I'm sorry that I couldn't have time to work it out, and I was just taking one of the previous course that was designed to teach the beginners of Introduction to R. And one of the tasks was trying to help them to try to port a graph look like graph they received. So, so instead of telling you about ggport 2 today, I'll actually apologize of going back to very basic of R, talking about the raw package of the R porting using the very basic function called port. So, for not a beginner in this, it may take will be a bit dull for you, but well, think about this as a way for us to teaching about the beginners. In fact, actually, in my presentation of these course, the people who are the students there actually was mostly social scientists, which has also background in some programming, but mostly in SPSS or Excel or Stata. So they was not familiar with the R syntax, and they actually say it's a little bit a bit difficult to follow. first place. So again, apologize for those who are also in the intermediate or advanced level of R. This will be a very beginner courses. So first, I actually set my working directory to get my data. The data is actually looks like this. So is actually I'm a pseudoscientist looking at the birth rate in Hong Kong. So on each column you will see that will the column 2 to 6 actually is the birth rate in Hong Kong in each year, and the age actually denotes with some age groups. So I was trying to use this to illustrate some of the line graph and bar plot. Right. So I don't need to talk about what is plot, but most people like this. And then what's the name? So at first I was trying to explain a little bit on the plot function. So basically you have the plot, you have the X and Y showing the age group as well as the birth rate. MT $ is X 1991, which is the birth rate in 1991 for particular age, for particular demographic groups. So I talked about how to make it into a line graph with the bubbles on, and how to, if you add types of equals O, how you can take out the borders, and you can also, sorry, it's BTY equals N, take out the borders, how you can change the dots into a solid dots by using the PCH argument, and you can also change the size of the dot by using the CX argument, and also change the line width by using the argument LWD. Right, and then at the time I was trying to take out the access, so you will use AX access equals to force to eliminate it, and also use Y label and X label equals nothing to take out the ugly part of the labels. So actually, I want to add my own creative one. So again, I can use access equal to two meanings on the left-hand side. So to put it back, by using another function called lines, you can add lines on top of the original ports, but change the white values. So we do it like that. So obviously you see there's some defaults in my graph. It's because on the new value MT $X2001, actually the white value exceeds 250. So it couldn't show in the ports. So in fact, when I dig in a bit, it was actually the maximum of this value is 326. So in order to do that, to put it back, I was introduce the concept of a Y limit. So I now put the Y limit to the minimum with 0 and the maximum with 350. So do it again. Now porting it again, I will have it back. Also, I can use line to add other values. Right. Now it looks pretty okay now. But the thing is, I actually want to change it, the color of the port, so make it more easily differentiable. So by do that, you will use the argument called color. So you can look a lot on the internet about how to what the value you can take in. So in this time, I was really trying to use a gray style port. So I was putting everything so using gray. Okay, so the port looks like something like this. Right. So now you see the color of each line changed it. So it shows a little bit better in terms of the in the graph. So let's say I want to do in the representation of this data. So I want to actually make it a bar plot. So actually you use bar port, but it doesn't take the it takes the data in a different way. In fact, you have to do the transpose to make the data look like this. Right. So you see, actually, it changed for each line, each column, or each vectors, it represent each age groups. So to make it like this, and I put it. Okay, I was trying to make it into a parallel form, so it looks better. Again, I'll use a y-limit things to change the y-axis, and also I use a name argument to give also do my x-axis label. And using a line or AB line, horizontal equals 0, I actually add a line at the 0 x as a horizontal line back, just to make it look a little bit better. So I do another things like a similar thing. All right. So actually I have 4 graphs, and I want to put it into a same layout, same graph. But well, for beginners, sometimes for me myself, I actually plot the 4 graphs out and either use a PowerPoint and put it together, or sometimes I actually use a Photoshop to do it together. So actually a bit stupid. So in fact, I offer a very good services called the layout, which I can define the layout I want to put it like this. I want to put a graph having 9 components. Actually, you later will see in the first 1, 2 components, which on the top row will be the label of the 4 graphs. 3, 4, as well as also labels. 5, 6, 7, 8 are the graphs I want to put it there, and 9 I will put a legend. So by doing this, I can able to fix the width of the graphs, the height of the graphs, and I also can make my own layout. So I've already defined the layout. Now I want to do the plotting. So the first, I actually use a little trick called use a bar plotting nothing at all, and then I'll add a legend, closing it in the center, and call it something called merit. The reminder that this graph is talking about the birth rate in Hong Kong by the merit types. Oops, sorry. Just do like this. And this one. So the same trick, but using this time is for non-married. Okay, so the graph is like this. Again, put nothing and then put something, and put a bar plot of nothing and then do a legend. Then on the 3, I actually call it a birth rate and a birth rate as well. Now it cramped up, but it will be better later. So now I do the exact same thing, put everything back, because it's 1 port, so it will go to the place I want, and also do this. Again, I do the port, do the bar ports, everything's go back. Now the problem you will see is that it all sort of overlap with each other. Because that I didn't edit the margins next to the plots, so it doesn't look very well. So to do that, we have to use an argument called PAR, which actually defined the margins away from each port. So the way you can think about this, the first one is the bottom is how much is away from the actual ports. So 0 denotes that there is no margin at all. So if this means that I would not want any margins for the first port, which is the label, which makes sense for me because it doesn't need any space at all. Again, is for the label as well. But now in the port, I actually want to put a 0 margin for the bottom, plus a 1 unit away from the left-hand side and 2 units away from the top. So you will see that in this time, should be a bit more space. All right. Someone still jam up. Okay. So again, I do this so you see a bit more space for each. So finally, I actually do also again a trick to put down all the legends there. Right, this is a very simple illustrations of how to use a space packages using nothing add-on from the R to do a simple plotting. And actually, this graph can be very easily replicable in the using ggplot2. So if there's the next chance, we shall talk about how to use the ggplot2. So that's the end of the presentations.
Thank you. Actually, we should have our fourth speaker, but he's still on his way. So I'm waiting for the questions from the people watching it from YouTube. But before that, I have a question for Jane. If Jane is still there.
Yeah, I'm still there. Sorry, just okay.
Yeah. The question is there some way provided by the Caret to calculate the evaluation numbers such as F1 score or the accuracy or the root mean square error, and maybe yeah, this is my question.
Yeah, I'm very new to this, so I want to say if there is, then it wasn't immediately obvious because I didn't find it through like a very rough Googling for it. There's a confusion matrix one, make a confusion matrix for you, which has, I think, accuracy and stuff.
Yeah.
But I don't know, and that's the next thing I need to do, is to value my data. The predict, can predict on the test data set what the response variables are. So I guess you can write it all yourself. But I don't know, actually, whether there is an easy way they provide for you to calculate all of this.
Okay. Oh, by the way, some people comment on the Facebook page, and he maybe comment on Facebook page and saying that we are talking about Python. Okay, actually we are not talking about Python. Even though I use it, things like this. Okay, let me show it to you. Even though I use things like this, it doesn't mean that I'm using Python. Actually, I'm using a thing called, let me show you the header. It's called Jupyter. Jupyter is a spin-off of the IPython notebook. Actually, the developer of the IPython notebook wanted to be language independent, so they spin off the IPython notebook into two different projects, which is one is IPython, the other is Jupyter, and the Jupyter is mainly for the web-based interface like this, and then actually you can switch between different kernels. For example, if you like to use Python, you can use the kernel as Python, and the new version, which is the Jupyter, it allows you to change to another kernel such as R. And because I actually like the interface of IPython notebook, so I used the Jupyter to demonstrate the function of a dplyr using Jupyter and the out as a kernel. The nice thing about the Jupyter is that it automatically formats all the tabular structure, for example, data frame into HTML table like this. And also it can display the inline graphics like the ggplot. And also you can export such notebook into our code, HTML, or even PDFs. So it make the notebook publishable. So which is very nice. If you want to know more about how to use it, you can Google for the Jupyter, which is the project, and you can just install it. As you can see, it supports many different kernels, not such as Julia, or Haskell, or Go, Ruby. But I think most of the people will use it with the Python, R, and Julia. And in case you're curious about the name of this project, Ju meaning Julia, Py meaning Python, and R meaning R. So they use it as a combination of 3 different languages, so that you can use these 3 different languages to use the Python notebook. Okay, and our 4th speaker is still on the way, still not here, and I'm still waiting for the questions from, if there is, maybe, if there is no question, maybe we can stop it earlier. And in case if you still have questions about our talk, you can ask in our Facebook pages, and we will still entertain those questions, even though we cannot ask them on the screen. And secondly, this live stream will be available for V1 on YouTube. In case you miss some of our talk, you can still watch it on YouTube, and you can also watch what we did on the first half an hour of the live stream, which is pretty crazy. So, anything to add, Jeff?
It's a good trial.
Huh?
It's a good trial.
Yeah. Jane?
No, it was fun. I want to learn your Jupyter. I feel like that was a much better presentation than the one I had. It was much clearer.
Okay, let's try it. Okay. That's the end of the conference. By the way, this conference is celebrating the 300 member of Hong Kong Our User Group. We may have another conference when we have 4,000 members, so stay tuned. And we will have a regular our meeting in the future. So see you later. And this is the end of the podcast. See you. Bye-bye.
Thank you. Bye-bye.